Welcome to Chemistry in the AM. Today we've got a out of sight weather day. Traffic is flowing smoothly down College Avenue right now. High of -2 today. So get outside and enjoy your sunshine. But today we're going to enjoy the insides in our classroom. Solubility, and this leads up to an experiment that we're going to be doing. Okay? Now, I think you guys roughly think of solubility as just in regular words, not even scientific. What is solubility? Something soluble. What? It dissolves in water, right? So we're going to just see, and this is without any mathematical measurement. That comes later. How many moles or grams? Well, that's not what we're figuring out. We're just saying roughly, is most of this a reasonable amount dissolve and stuff? So we're going to start by example, and will the following be aqueous in water? Now, I'm going to just show you all of these, and then we're going to go through it. So I'm going to pause the video, copy these A through G down, and we'll do by example. We'll learn this, okay? On your periodic table handout set, can you guys find this chart? I think, is it the second page in? Okay. Soluble compounds in water. It's not an exhaustive list, but it's most of the ones we'll come across in chemistry. You need your handout set? You can just use this one. Okay. So, on the top of your handout, though, the one that you'll use in tests, write down what I have in blue. Soluble is AQ, aqueous. It means it dissolves in water quite easily. Low solubility, we'll say bracket S, it's a solid. We'll talk about how to use it, but that's how to interpret this. Now, explain this, and I'm going to just, you don't have to write this one down. On board, not working on it. Just working. I'm going to pause the recording. Okay. Like I was saying, something that you know is soluble in water, sodium chloride, table salt, right? I have one AQ. Now, you can look it up on this chart. The first rule is that essentially everything mixed with sodium, potassium, lithium, can be soluble in water. Okay. That's up to a point, too. You know and I know. So take a cup of water, add sulfur, stir it, it'll dissolve. The better word is dissociate. It separates into sodium ions and chloride. But there is a point where it'll become saturated. So you got a ton of sodium chloride dissociated in the water, but then if you keep adding it, you're going to have sodium chloride that piles up on the bottom, right? So this doesn't tell you the amounts. This is just telling you for a reasonable amount of dissolve, and we'll talk about amounts. Now, let's take a look at the one that I have. Now, the first one, Ki, things that you're not as familiar with, potassium iodide. That's the K plus ion and the I negative iodide. When I look up this one, I'm trying to figure out, is it soluble or not? Well, right away, I look at the first rule on your list. And pretty well anything mixed with potassium will also be aqueous at all times. What if I looked it up the other way around? I looked it up for the I negative ion. I didn't notice rule 1. I see I negative, iodide. It's in this batch of rules. It says that silver, lead 2 ions, mercury 2, copper 1, thallium of low solubility. They be solids. But anything else is soluble. You'd still come to the same conclusion. Aqueous. Follow me on this? And you'll notice that where are lithium through francium on the periodic table? Like where are they located? The first column, right? Family 1, group 1. Okay. So really what that first rule is that anything from group 1, hydrogen's not included on the list. Okay. But even hydrogen. Anyway, group 1 elements don't form solids. That's what the first one is. So if you catch that, you see how we just have hydrogen in this separate rule just because it's acid. But really, that's what rule 1 and 2. Group 1 elements, no solids. Anyway, okay. Anyway, you can do it the other way around. But I'm asking you to just write in AQ, and I don't care which way you did it. You recognize these group 1 elements? That's great. But you'll notice after the first 3 rules, which is group 1 elements, and then ammonium ion. And you'll notice on the list that I've given you for the ionic ionic ions sheet, ammonium NH4 plus is the only polyatomic positive cation on the list. These don't form compounds that are solid anymore. They can be readily resolved or associated. So that means from here on, you have to look up the negative. You don't recognize a group 1 element. So we're going to do B, NO3 negative. Well, that just happens to be the 4th one. And just erase the blue circle. So what I'm talking about here is the 4th rule, nitrates. Any positive mixed with a nitrate, any cation mixed with a nitrate, essentially all of them, are soluble as well. And soluble means, there we are. So as soon as you see a group 1 element, or you see a nitrate, you can just right away write down this. There's the first 4 rules. Now the other rules I'm not going to go through every one of them now, but they all involve negatives. And what we have to do for the next one, next 2. Don't look up there. That's what 4 rules. It's kind of your sandy. The 7th rule. And if you look it up right away, SO4 2 minus. What does that mean that this copper is? Because there's actually 2 types of copper. Copper 1, copper 2. Which copper would this be if it's SO4 2 minus? And there's only 1 of each. There's 1 group of SO4 with a 2 minus charge. What is the copper's charge then to make that add to 0? Plus. And I look through the sulfate rule. I don't think copper 1 or 2 in these list. So it must belong to others. Soluble. That makes sense? Soluble means it. Might have noticed as we're looking on there for a second. I now see though that the same rule, sulfate, but this time it's calcium, CH. And it's the first one on this list of exceptions. Low solubility, right? Which is why I'm talking about that. Mixes with calcium, sulfate, together. Finally, we have a solid. It's not going to dissolve well. got a kettle, boil water and stuff. What starts building up inside the kettle slowly over the next year or 2 or 3 years on the inside? It kind of looks, it's not gross. It doesn't look shiny if it's a metal kettle on the inside. What's building up? What deposit? Well, do you ever see a white kind of solid building up on the inside of a kettle? You have? That's calcium, typically. And it comes out of water. We have calcium naturally in water in small amounts. It's just, we call it hard water here. That's why you have a water stop. Take out extra ions, various ions. Anyway, so the calcium ions easily become solids. So that's why you've got that happening slowly over time in the kettle. And it's probably because you don't wash out your kettle every day because it's sterile, because you're boiling water every time you use it. Whereas in your pots and pans you use for cooking, after you cook, you tend to wash it out so it doesn't lack the calcium. But if you didn't, don't recommend this, because there'd also be mold growing on your pots. But if you didn't wash your pots all the time, stuff like this, you probably have calcium deposit build up. Sometimes around taps and stuff like this over time too. You get that white buildup on the inside of the spout, fill-in spout. You might not. Depends how good your softener is working too. Okay. Silver chloride, copper, copper. I'm going to just mention something here. Chloride, all three of these, is Cl minus, right? So does it make sense that this is copper plus 1, this is copper plus 2? I tend to write the 2 first and then the plus. You put plus 2 as you notice there, either way. I do it interchangeably. I use all of them. So I'm going to go into this chloride in there. Whether it's chloride, bromide, or iodide, they all flow the same. Okay, so I take a look. First, I'm saying copper with silver. I look through the chloride rule here, and silver happens to be the first thing. Low solubility. I'm going to just put a solid there. It's going to be a solid in water. It doesn't dissolve. Copper 1 and then copper 2. I'm going to look here. Notice that copper 1, that happens to be what we're looking for. There's also low solubility. So, the copper 2, though, is not the same. It's actually quite a different chemical. It has different reactions. And it's one of the others then, because it's not explicitly listed there, so we say it's aqueous. It doesn't form. Okay. Now, copper is one of the ones you got to watch for. Is it the 1 or the 2? You got to work backwards sometimes to figure out what the triad was. I'm not going to go through all of these rules, but just have your wits about you when you're doing this. Like, the way they list it. Like, for the ones that I was doing so far, the list with ions is low solubility, right? But then all of a sudden, this one here, the ones listed are actually soluble for sulfur. You notice that these bottom 3 list the ions and dissolve, dissociate, as a solid. So double check. Don't just assume if it's in the first batch that it's a solid. The bottom 3 are not. So, any questions there? Next. Next. Pause the video. Okay, we got these copied now. Let's see if we understand the problem. First of all, what are the compounds? This is more like grade 10. And then aqueous or solid is grade 12. So Pb2 plus can't mix with copper. Two positives don't come together. We're going to say Pb2 plus with the iodine. What's the formula of that? How'd you know it was I2? You're right. Yeah, you have to add up to 0 inside the column. So I think 2 plus, 1 negative, right? So in a sense, I think crisscross. 1 goes here, you don't have to write down 1. And then I2. You guys talk about crisscrossing and formulas in grade 10? Maybe you did, maybe you didn't. One of the compounds. Let's write all of these out. The other one would be Pb. Now, the sulfate, 2 plus, 2 minus for the sulfate. You see they're a perfect match. I don't have to adjust the numbers. I just have one group of Pb2 plus with one group of SO4. Proper compound, an ionic compound, should not have any charge, any positives. Now, for the same reasoning, copper, 2 plus an iodine, CuI, CSO4. That's it. Just combine those out. Let's see what happens. Now let's use that chart, right? Now, you're going to see I've repeated. I have this down here. But I want to go through the logic for that. So what I want to do is flip back and forth. Or instead of flip back and forth, yeah, yeah. So I'm going to go page. Now let's take a look. The iodine rule. I'll do the lead iodide and the copper, the lead 2 iodide and the copper 2 iodide. So iodide belongs to this. You notice those are all column 17, right? Br, Cl, and I. Okay, you notice that lead is low solubility, so that's going to be salt. You also notice, though, that the copper is not copper 2, it's copper 1, so it doesn't fit in that category. Copper 2 belongs to the soil. Right? I want to show you one where it's different. Well, let's just jump this in. We said that lead belongs to the solid. Let's check out the sulfate category. Sulfate is the 7th rule. Once again, I see lead in that category. All others. Well, I guess copper must be one of the others. Does that make sense? Okay. We know how to reason through these things. Hold on. Step further. Always have to go a little bit further. Move this here for now. And do we need to do all of these? How many of these do we need to do for practice? 3? You guys agree with that? ABC. Do 3, and then we'll pick up the others. These involve you actually looking up what hydroxide is. So you can say sodium hydroxide, write out the formula. Ammonium acetate, write out the formula. Calcium sulfate, write out the formula. If you need more practice, you're welcome to do 6, but I'll pick up 3 with you right away. Good suggestion. Pause the video. Jot those down. So to take these up, I heard the formulas. You guys get these? The first two are actually those no-brainer rules. Sodium is in the first column, it's the first rule. Always is. But if you looked it up by hydroxide, you'd also get ammonium mixed with acetate, aqueous. When you look up acetate, though, pretty sure the way our rule is listed, it's only silver that does form solids in it. So pretty well everything except silver. Acid. Calcium sulfate. I thought we did calcium sulfate on the first page. It doesn't matter. If you're interested in doing the others, I have this on video. Obviously, there's the answers. So that's if you think you need more practice. Go ahead, try it. But I mean, I'm not going to pause for time. Because where does this go? This, I was telling you, this is leading up to a lab. Here's where it goes. You have two beakers. One beaker has bromide ions, one has carbonate ions. How can you tell the beakers apart? We'll do this together, but I'll let you jot it down first. Okay. We understand. Here's what it is. I have a lab. Oh, start closing. Now, I've labeled them, but I'll just call it solution B, solution A. The unknown. You've got to use your chart. We've got to look up Br minus and CO3 2 minus to find something. Hopefully we have it in our lab that we could add. Here's Br minus. And CO3 is spot a little bit. Carbonate, CO3 minus. Okay, so we get the idea. Something that you can add to one that makes a solid with only one. Okay. One but not the other. So the first obvious thing is to take a look at the first category. If you find something in both lists, then it will be soluble with one and not the other. So I'm going to look through here. So, not in this other list. No. Most of these are all group 1 elements. And then hydrogen, ammonia. They're the first three rules, right? Are any of these group 1 elements? No. Okay. We're not going to do it easy. I wish. I do that. Okay. So with that, we got to think in this kind of backwards thinking. Abstract. Not too bad. All the others. Now, we don't have all the others listed here, so we can't cross-reference them. We've got to think, well, all the others are things that are not on this list. And all the others vice versa there. Basically, all the others that aren't in group 1. I think it's easier to think about the 10th rule. Give me an ion that isn't in the first column. Strontium. Okay. Strontium 2+, second column. Okay, let's think of this one. This is another. There's a dozens of answers that could come up. And strontium plus is another. It's not in that list, right? Apparently, it's going to be soluble with the bromide and the carbonate. It'll form a solid. Right? So if I have strontium ions in mine, I actually don't. But I mean, this would work. So let's just see. Like once, you probably never heard of strontium too much before. You've heard of iron, though. Could you use that? Could you use copper 2 plus? Too. That would work the same way as the strontium 2 plus. There's, like I said, there's dozens of ways to do it. Strong? Okay. How could you tell that you add SR2 plus 5? I'll tell you this, though. You can buy strontium ions alone. It comes in a compound, but it'll have to be an aqueous compound. So that it doesn't do unintended reactions. And the easiest way to your default compound, if you're allowed to have it, I'll let you know which one, is nitrates. You can mix anything with a nitrate. Strontium nitrate will be. So I'm going to list this here. SrNO3. I put a round bracket in front, and that gets confusing with that round bracket. You can't just add strontium ions. So that's what we're going to add. You're writing this answer. Because I'm kind of giving you a recipe so you know how to use it. And add SR2 plus. You're going to tell me the nitrate chemical. That's a good key question. That would work. We'll just get plain old strong. Now, what's going to happen with the BR? That's on the BR. Add SR2 plus. So the SRBR2 form of solid or liquid. That's not going to do anything. That means that's going to remain clear, no solid. So then I test the other one. SR2 plus CO3 2 minus. So I'm going to write this one down. It's the one. Let's verify it. That's add strontium to this low solubility. It'll form a solid. So now you know that was the carbonate beaker. The other beaker must be the Br minus. So now you've identified the two beakers, right? Now we're going to take this a step further. And we'll actually try it next week. I'll tell you ahead of time which count. Yes. Yes, I'll record that. And it's all handwritten. No. Oh, this is my writing. I'm going to just erase this. A series of tests have to be done to separate calcium from silver ions in solution. I'm saying separate. Similar problem. We'll talk about the difference. So I wanted to do an example like this because this is two positives. Yeah, it is two plus, so it is two plus. So I've got these in one beaker. solution. Plus ions, silver ions, calcium, silver ions, both in 1 meter. Separating, well, if we can get one to form a solid, not the other, and filter it off, we can separate. In theory, you actually don't filter at all. In our lab. So, there's ways of purifying. The problem is that there's no positive categories. These are all, other than the first 3 rules, they're all arranged by anion, not cation. We're going to look for a category that lists calcium and not silver, or vice versa, silver and not calcium, right? There's more than one way to do this. I'm going to give you guys a minute to tell me. I'm waiting. There's one really obvious one. There's more than one way to do it. You're looking through these rules, right? First 3 rules don't help you because they're listing categories. No good. Nitrate doesn't help. Talk to me. Sulfate are here? Yep. Good. Okay, calcium and silver are both listed here. They will both form salts. I want to separate. So that would take both of it. That was it. Well, that's not going to help us. Bromide. Okay. Silver and not calcium. Bromide works. So the silver would be left behind. We form a calcium. What about this one? I thought this one was super obvious. Silver, not the other. Okay. And is there others? Sulfide. Sulfide. Let's take a look at the sulfide here. Calcium would not form a solid. Silver would. Okay, that would work. What about this last rule? Oh, okay. The last rule doesn't have anything. What about this one? I'll be darned. Calcium is not listed. Or silver. Okay. So these ones are no good, eh? We have our choice. Which one do we want to choose? Sure, acetate. Chikun. So we could add, that's the acetate ions we want. So I'm going to add, though, we can't just get a bottle of acetate. I'm going to add sodium acetate. So I'm going to put Na, CH3CO, CO. Okay, and it's not a solid. That's adding the acetate ion. Now, do you guys remember these double replacement reactions? This is where the sodium and the acetate separated in water. The acetate will combine with the silver. Here, so what forms? Oh, I don't know why. We have AgCH3C solid. Filter that out and calcium ion. It's not in the beaker, I guess, in the solution. kind of see that reasoning? Yeah. Yeah, that's why they calcium ions. So what happens is, erase one function. All of a sudden, then you add this, and it is all the silvers turn into Ag. Got enough. Because I can't just find a beaker of acetate ion. Oh, I generally default to Na. Sodium acetate. First of all, I have lots of sodium compounds, and they never form solids. So generally, your default is if you're adding a negative anion, just say sodium bromide, sodium iodide, sodium chloride, sodium, and that's the question. So you see this, and I'll put solid right here. I shouldn't have put a bracket around it. I might have. We filter that out. It takes out the silver compound, and the calcium will be dripping through. You can separate it. You could do something else to capture the calcium. Now, time remains. Take a look at some questions. I'll hand them up.